We're going to first of all kind of go through the simple process of setting up a few things, and then of course troubleshooting some things with that tool. So first of all, let's just go ahead and talk about where you can actually get it. The DesignMATE segment verification tool that we have can be found at our website, fieldbus.org, under the End User Resources section. If you click under End User Resources, it'll take you over to our landing page where you can either click up here at the top for technical references, or of course you can do the same thing by clicking down here within the page. Now if you scroll to the bottom of the technical references page, you'll see we have the design tools section, and specifically the free download for DesignMATE. It's a very good kind of gut check tool used for verification kind of thinking or possibly you're planning on making an addition to your plant, and you're kind of trying to get a rough idea of the devices you're going to need, the wiring you're going to need, what sort of specifications or standards that those things will need to adhere to, etc. So without further ado, I guess let's go ahead and get started. So here's DesignMATE, and I'm going to go ahead and create a new project. And I'm going to run you through here just a little bit about everything that you're seeing on the screen at the moment. Over here in the device tree, we have host, power supplies, wiring block, device coupler, surge protective device, field devices, and terminators. Here in this section of the screen is where you're actually going to build your segments. So we'll get to that in a minute, but this is anyway the area that you're going to be working with. And then of course over here for the property editor is where you can select the defaults or some additional information particular to your device. So for example, over here you're going to be looking at things like your segment type. You can pick the cable type that you're going to choose, right, for your particular installation. You can get a temperature range you're going to be doing, some of the field device current, the default spur lengths, and the handheld current. And then of course you got all of your checkboxes here for the defaults for all this stuff. So anyway, let's go ahead and just kind of get started, and I'll actually just click through a couple of steps here just to kind of show you guys what we're doing, and then I'll move on to a segment I've already completed just to speed things up a bit. So it's really as simple. It's a drag and drop methodology. So in this case you want to pick a host for your system, right? And again, like I said, if you'll notice over here, you can even give your host a tag and a description, as well as input current, things like that. But let's go ahead and then go down here and pick a power supply that you're going to use. All you got to do is get close to it. See how it automatically connects? It automatically will drop that wire right there. And again, same thing as before. You can give yourself a tag, do some voltages and description, and then let's come on down here to a coupler, right? You want to do a coupler, maybe create a spur to it. Again, all you got to do is get close wherever you want it. You can see how it starts tying itself to it. Well, there we go. Let's go ahead and just pick that. And then of course you can pick a bunch of different field devices from all the different manufacturers that are currently registered under the Fieldbus Foundation. And that's actually a really good thing. You want to make sure that you're always going to be using registered devices in your plant. It's definitely something we recommend, and at least that way you have some sort of standard of interoperability that is going to be there. So again, this is sort of the overview, and you can see all the different parameters of each thing, but I'm going to go ahead and minimize this and open one that I've already completed. And as you can see, right, I've even named this thing host, and a power supply, I've named it Fieldbus Power Supply. Of course you'll give it whatever tag you want. And then same thing here in each spur, as you say down here, is 90 meters. It's just a default that I selected for this particular project. And then of course you can see all the devices from the different manufacturers that I've put here, and I've named them just to be clear. I've kind of got a good selection of a little bit of everything, just to give you guys an idea of what we're going to be dealing with here. So another very important aspect of this tool that I wanted to show too was that not only can you build these segments and then save them, print them, duplicate them, use them as templates for kind of boilerplate designs that you want to use at your facility, Anyway, the great thing that I was going to point out here was that you get this thing called a project report right down here. This project report, if you click on it, will give you an overview of your segment and if anything is wrong. And as you can see here, we've got a failure notification. So if you scroll down right here, we can see a terminator is missing. So automatically the system is telling us, hey, something's going on and you need to check this thing out. So let's go back to the segment editor and we'll notice, yeah, you're right, we didn't terminate out here at the power supply, right? And as you know, installing Foundation Fieldbus, you need a terminator at the front of a segment and at the furthest point of that segment. So it's really simple actually. On here you can just click terminator right here when you do it. Now that that thing's terminated, we should be good, right? Well, let's go back and check under the project report. If we're back up top, we're still getting a failed notice. And again, terminator missing. So if you read the details there, a trunk must be terminated at its end. So we've got one at the beginning, but we forgot one here at the end, at the coupler. So let's go ahead and terminate that as well. So see, instantly you can start seeing values pop up. It's telling you a load status and what kind of milliamp draw you're getting. And you can see the whole segment. Now again here, look, red flag. Right here you know something's going on. There's a red box highlighted around this Yokogawa device, right? So that's sort of an interesting thing. So again, let's go into the project report and let's try and get more information, dig it up, right? And under our checker summary, power distribution check was failed. Okay, so what does that mean? Let's scroll back down here. It tells us the calculated current is too high. The required current 26 milliamps for the device exceeds the maximum current of 25. Okay, that's interesting. That means, that's telling me right here that something with one of those spurs, in particular that Yokogawa, is exceeding this maximum current of our coupler, right? So if we go over here, click on coupler, yeah, sure enough, right here under maximum current, we've only got 25 milliamps and the Yokogawa needs 26, so it's throwing a flag at us. In this scenario though, what you can actually do if you're uncertain is go back to your particular product specifications for that product and double check it. In this case, with this device, let's say I go back to the web or I go back and dig through the pamphlet that comes with it, and I notice that, man, I don't know what happened there, but it shouldn't have been 25 milliamps. It should have been 41 milliamps was the maximum draw, right? So let's adjust that, and look, red box goes away. So now we've got what appears to be a good looking segment, but let's verify. Let's check our project report. We go back up here. Sure enough, success all the way around. So we've actually got a full segment with host power supplies, couplers, and devices, all with their own spur lengths and cabling and instruments, all these different things. And everything is checked out perfectly. So this is a good way to kind of build segments and predict new things that you guys are going to be possibly doing in the future and plan for, and to really, you know, be a good gut check and verify what you're thinking.